Hello everyone. As part of learning big data framework, today we will be starting a concept called AVRO, which will help us to serialization, exchange of data and interoperability. That means the data which is stored in one language program, using one language program, can be used by another language program without much complexities. So let us talk about the tool which is helping to do various tasks like these. So we will be learning approximately 3 to 4 frameworks which are helping in these things. We will be learning Avro, we will be learning Parquet, we will be learning Flume, and we will be learning Scoop. As part of the sessions, we will be learning through these 4 tools. So let me start with Avro. Now, Avro, as it is coming from Apache, it's an open source project which will help us for data serialization. We know what do we mean by serialization and deserialization. So it helps us the concepts of data serialization and also exchange of data services between Hadoop and various other language frameworks, etc. And these services can be used as a collective service, like I want to do both serialization and exchange, or I can do independently, I can use those services. And Avro facilitates exchange of big data between programs written in any language. So I need not worry, suppose I have written a program in Java and I was maintaining my big data and somebody wants to access the same data using a program written in Python. So how do I take care of this? We need not worry about, Avro will take care of language transfers, the data between various language structures and all, by using concepts called interoperability. We will be seeing them very soon. So Avro facilitates data exchange between programs written in any language. With the serialization service, what is happening, programs can efficiently serialize their data into, either I can store them in files or I can store them into messages. The choice is again left to the user. And data storage is compact and efficient because Avro stores the data as it is trying to store both the data definition and the data together in one message or file. So it will not try to separate them, it will try to put them in one place, both the data definition and the data. And Avro also stores the data in the format of JSON, wherein it will be easy for us to read. And also it will try to put the data in binary format so that the space occupied will be comparatively less. And Avro files include markers, we call them as sync markers. Even if the file is split into 1 or 2 blocks, it identifies where a block is ending, where a block is beginning, using something called as sync markers. Right. So Avro files include markers which can be used to split large data sets into subsets suitable for MapReduce program, because during MapReduce we have learnt if the data set is of huge size, it will try to split them into blocks depending on the default block size defined for HDFS. So likewise, whenever we are trying to maintain our files in Avro, it is trying to remember the block beginning and ending using something called as sync markers. So I will show you the file format also, how the data will be maintained in Avro. And what exactly some of the features, all these are features supported by Avro. So some data exchange services use a code generator to interpret data definition and produce code to access the data. So some of the exchange services, what are they doing is, they take help of a code. They try to use the code generator for both storing the data as well as to access the data. And Avro does not require this step, making it ideal for scripting languages. So when you are working with Avro, you need not write huge lines of code, just like a small script you will be writing, which makes it easy for the users to work with storing huge amounts of data. And a key feature of Avro is to robust support for data schemas which keep on changing over time, and we call this process of changing the schema very frequently over time is called as schema evolution. And whenever the schema is changing, I need not do much changes to the access mechanisms and storage mechanisms if we are working with Avro. So Avro automatically takes care of schema evolutions. And Avro handles schema changes like missing fields, added fields and changed fields. As a result, old programs can read new data and new programs can read old data. So these 2 points, if you try to understand collectively, what do you mean by schema change? Schema is the outline structure of the database, we know this. So what changes can you do for a schema? You can try to add a new field, or you can try to remove a field, or you can try to update a field which is already existing. That's all we do with alter command. If you remember SQL, what are the options with alter command? Alter is for changing the schema definition. Alter, add, modify and drop. These are the three options we have. Add, I can add a new column. Modify the definition of an existing column. Drop, delete an existing column. So with these three options, we are trying to change the schema. So whenever you are trying to change the schema, Avro handles the schema changes like missing fields. You might have dropped some of the fields, added fields, you might have added a new one, or changed fields, you might have updated the definition. So it automatically takes care of those schema evolutions. Thereby, already I have written a program using the old schema. Now the schema has changed. I need not go and modify the program or the access mechanism, right? And also Avro includes APIs for Java, Python, Ruby, C, C++ and many more languages. So data stored in using Avro can be passed from programs written in different languages, even from a compiled language like C to a scripting language like Pig. So this interoperability gives a huge power to work with huge amounts of data while trying to reduce the burden on the part of the user. So Avro is taking care of all these mappings between various types of languages. Then an Avro data file has a metadata section. Whenever we talk about maintaining the data, we are not only storing the data, we are also maintaining the metadata. So does Avro. So an Avro data file has a metadata section where the schema is stored, which makes the file self-describing. So whenever I see the metadata, I can understand what exactly is happening with the data. Avro data files, they also support the concept of compression and one more thing, splittable. While learning the concepts of compression, we have discussed about splittable compression. So Avro is supporting compression as well as the compression supports splittability, which is very crucial when you are working with MapReduce. And Avro also supports all data processing frameworks wherein you can try to work with Pig, Hive, various frameworks that are available with Big Data Hadoop. Avro can also be used for remote process calls, RPC. Right? So if someone asks you what are the features, you can at least list out some of the features, right? Then Avro data types and schemas, whenever you are trying to define schema using Avro, what are the data types that are existing? The fundamental primitive data types of a language, how are they mapped into Avro? Do I have only primitive data types or do I have complex data types? Let us talk about various data types which are available in Avro. So when we are learning Avro, these are the primitive data types of Avro, wherein you have a boolean which is null, which indicates the absence of a value. So there are consistent definitions. We don't change the definition from framework to framework. So whenever you are learning Avro's primitive data types, wherever you have a null, it is showing absence of value. Boolean, we are working with Boolean values. Boolean data type is there which takes only possible values to true and false. Then when you are working with integers, you have various types of integers, just like C language, 32-bit signed integer and 64-bit signed integer. There are two types of data coming to integers, int and long. Float is there, which is a single precision 32-bit float value. Apart from this, we have complex data types also. We have arrays, map, and we have record, enumerated data types. We have fixed data type, union is also there. So these are various data types, complex data types. We call them as complex data types of Avro. Let us quickly look at them. Array is an ordered collection of objects. The array definition doesn't change much. Maybe if you are working with primitive integers, it's a collection of integers. Here, because whenever you are working with files, storing the data, they are objects. So it is an ordered collection of objects. All objects in a particular array must have same schema. Does it confine to the standards of array definition? An array consists of homogeneous elements, right? So instead of homogeneity, here we say all the objects are following same schema, right? Now say for example, I want to define what is the type of the data structure, array, and what are the items data type, long integer data type. So you are trying to give an example definition also. Similarly, I want to work with map. Whenever you are working with map, it's an ordered collection of key value pair, right? So whenever you are working with map, it's an unordered collection of key value pairs. Keys must be strings and values can be of any types. So you are not specifying what is the data type of keys. So if you see the example, you are specifying what is the complex data structure type, it is of map type, and straight away you specified what is the data type of values. Why didn't we specify the data type of keys? Keys must always be strings. So it is understood whenever you are working with map, keys are strings. So you are not even mentioning what is the data type of keys. Only values data type depends on the customer's choice or the application. Similarly, map can be of any type, although within a map all values must have same schema. So all the values, if I define string, so you have all the values as string data type. Similarly, quickly look at record. This record is similar to, not exactly, similar to C data C's structure. Struct keyword is there for user defined data types. So record is similar to structure in C language. If you see, you are trying to define a type as a record. What is the name of this record? Weather record. What is the document? A weather reading. You are trying to give the example also. And what are the fields you are trying to have? I have year. What is the data type of year? Integer. Temperature, integer, and station ID, string. You are trying to define records. Similarly, you have enumerated data type. Enumerated, for the enumerated data type, internally it represents it with integers. Then fixed, whenever you are trying to work with the fixed data type, it's a fixed number of 8-bit unsigned bytes. So maybe I am trying to say this is the one, size value is 16. And union, just like C language union, we have union definition also. So you are trying to talk about unions. It's represented by a JSON array. Every element in the array is a schema, and data represented by union must match one of the schemas in the union. So every element can have its own schema. At least it should match one of the elements schema. Let us talk about Avro API mapping to language types. What do we mean by this? Each Avro language API has a representation for each Avro type that is specific to the language. So what do I mean by this? Whenever you talk about mapping, say for example, I have written a program using Avro formats and I have used Java language. You are accessing the same file which is represented by Avro, but you are using Python program language. Already I have written to store the data, but I have used Java. You are trying to access the same with Python. How does Avro takes care of mapping for the data which was maintained using Java to be accessed by Python? So although there are not much differences between these two languages, it will try to take care of the mapping. Whenever you are talking about mapping, this mapping is of three types. When you are saying mapping, generic mapping will be there, specific mapping will be there, reflect mapping will be there. What exactly? And all these three types of mappings together we call them as, they come as dynamic mapping. So all the languages, they are supporting dynamic mapping, which can be used even when you don't know the schema definition, and Java calls this as generic mapping. The Java and C++ implementations can generate code to represent the data for an Avro schema. This code generation is called as specific mapping in Java. Now what are we trying to do? We are trying to give implementations which we are using, where the customer is using or the client is using the applications written in Java and C++. But I want to use in the backend Avro as the data maintaining service. In such case, I have implementations which are specific to maintain the data in Avro, and the program can be written in Java and C++. So such a mapping wherein you are trying to go for only Java and C++, you are specifying. So this mapping is called as specific mapping. And Java also has one more kind of mapping called reflect mapping, which maps Avro data types onto pre-existing Java types using reflection. What is the meaning of this one? Java, say for example, might not have union, say for example. In such case, Avro data object is there which is belonging to union. It should be mapped onto Java. There is no exact data type that is matching to this union. So whatever is existing in Java, onto that existing one, this union will be mapped. So we call this as reflect mapping. If the data types are exactly matching, that comes under specific mapping. If they are not matching but you are trying to use an existing data type of the language, we call it as reflect mapping. Otherwise, when the schema is not known but you are trying to go for mapping, we call it as generic mapping. And in-memory serialization and deserialization, whenever we are working with Avro maintaining, it goes for in-memory serialization concepts and data deserialization concept. Say for example, I have a record like this. What is this record consisting of? It's a record and its name is string pair. By seeing this, you can understand there are two items in this structure or record. There are two strings and we are calling it as a pair. What are the fields? Name is there which is of type string, name is there which is of type string, maybe like first name and last name. So you are having a pair of strings. Now whenever you are trying to work with this, if this schema is saved in a file on the class path called stringpair.avsc, stands for Avro schema. AVSC extension stands for Avro schema. We can load it using this line of code. Try to identify the line of code. Similarly, I want to create an instance of Avro record using Java API like this. And also, how are we going to serialize? Just go through this one. And whenever we are working with Avro serialization concepts, we have two types of objects: datum writer, which takes care of writing the data onto output, and you also have encoders, which will take care of writing the data onto output stream. Thank you.